We are now beginning lesson C5 in algebra. This is also in your textbook lesson 5.8, graphing absolute value functions. Now think about when we graphed some of these before. I've listed the I can statements and you can see the standards that are listed, but as you look at these I can statements, I can explain the parent function of an absolute value if f of x is equal to the absolute value of x. I can explain why absolute value is considered a composite function. I can identify, think of composite, of putting things together. I can identify key features of the graph of an absolute value function. I can identify the vertex of an absolute value, that it will be the minimum or maximum just by looking at our equation, and I can graph absolute value using an evaluated point. The last part of it is that I can predict what the graph of an absolute value function will look like, comparing it to other parent functions. Key thing we want to remember, what is the definition of absolute value? It's the distance away from zero. So what is 3 units away from zero? Both 3 and -3 when we look at that. What is 4 units away from zero? Both 4 and -4 would be that same distance away. If you need to read those through again or look over them, take your time in your note guide and do that. Graphing absolute value functions. When we've started graphing, we've always made our table. I would like you to add one more to the table. We're going to put in our x values of x, 1 or 2, 1, 0, -1, and I'd like you to put in -2. So add one more to our table. When you look at finding the absolute value of 2, if we put that in, and what we're doing is we're replacing this x value with 2. That comes out to be 2, 1, 0. What is the absolute value of -1? It is 1, and this is 2. So when we go to plot our points, remembering 2, 2, 1, 1, 0, 0, -1, 1, and -2, 2. And what happens with absolute value is you always get this nice V shape. It is like putting two lines together. So it says this is our parent function for absolute value. Can we describe the shape? And then is it linear? So our shape, we would say, is V. It's a V shape. And really these both go on forever and ever. So it's a V-shaped graph. The vertex of this graph will always be located at 0, 0. The origin. It opens upward, and this will always happen anytime we're working with absolute value and it's positive. It is definitely, I want you to think about this if you look at this graph. Is it linear? It is not linear by any stretch, okay? Does not make one nice straight line. It actually is made up, if we wanted to think of this, it is made up of 2 linear rays. That's why we kind of think of it as a composite function that extend from our origin. Again, if you need to pause it as you're watching this to write it down, please do so. At the top of the next page of your notes, we kind of talk about a translation. A translation is a shift either horizontally or vertically. So horizontally is moving it left and right, vertically moving it up and down, or it could be both ways. The result is a graph with the same size and shape but a different position. You can quickly graph absolute value functions by translating the parent. If I have the graph of y equals absolute value of x, that's the one we just graphed, and it says this is the graph of y equals absolute value of x minus 2. How are those two graphs related? Well, let's take a look. What's different about this? It moved down 2 units. So it says to translate it vertically, up or down. How does that change? And what we want to keep in mind is if you add a number, so if we add a number to the right of our absolute value. And I also like to think of it, instead of just to the right of our absolute value, outside the absolute value. So if we wanted to think of it, is that outside of our absolute value. Okay, so we're outside of that absolute value bars. The V shape moves up if it's positive, down if it's negative. The number that you add or subtract. In our case up here, it was absolute value of x minus 2. That whole graph shifted down 2, and then it was the exact same shape that you add, the number that you add or subtract. So, as we take a look at this, on the next page of your notes, in that bottom part, it says, okay, we want to translate it x plus 2 and x minus 2. I want you to take a look at this. If we translate our parent function in the black here to the absolute value of x plus 2, it doesn't move to the right 2, it moves to the left 2. Here, our parent function is in the black, and we're looking at y being the absolute value of x minus 2. Again, you kind of think subtracting 2 should move to the left. It actually does the opposite and moves to the right. So it says, well, what could we predict then about this graph? I want you to kind of make that prediction right now. I want you to think about that and make the prediction. What's going to happen to this graph from our parent? So we would want to be thinking, try it on your own first. Y to the absolute value of x plus 5, and that is an absolute value sign, will move. Try it your own, then we can look at my prediction. 5 units, if we are looking at it, to the left. 5 units to the left. If we are thinking about that, our new vertex, instead of it being at 0, 0, will now be at negative 5, 0. And the kind of thing you want to think about is what actually makes this y value 0. And negative 5 plus 5 does give you 0. So when we look at our graph, we have our y and x axis. We would have had our parent function, again we'll make ours in black, just like they do up above. The parent function, this is our y equals the absolute value of x. And now we are going 1, 2, 3, 4, 5 units over. And we now have that same graph, and in this case, same shape. This is our graph of y is equal to absolute value of x plus 5. Pause it if you need to watch and rewrite it and look at those points. And at the top of the next page, it says, okay, what can we talk about reflecting it? Meaning here's our parent function. If we reflect it over that x-axis, it's going to now be a negative out in front. And then the other one is called a dilation. A dilation either makes it much steeper, like in this case, multiplying by a number greater than 1, or it makes it much smaller or much wider by multiplying by a number, again, that is between 0 and 1. So any fraction or decimal we put out here is going to make this a much wider graph. So let's compare these ones, and we want to write a summary of our observations. So this is going to kind of take me a little while as I'm writing it out. So as you go through it, kind of you might need to pause it after I write it. But it is that the number, if we are looking at this, the number that is multiplied is being, the number that is being multiplied by the absolute value affects the slope. That's the steepness of it. That's like these dilations and the last two. The steepness of the rays. And how does it do that? Well, one of the ways that we want to think about that is, first, if it's negative, anytime you have any negative number, it's going to reflect it over the x-axis. So that we're really talking about our parent function went up. If we multiply by a negative, it's going to be going down, same shape. If the number, as we talked about, is bigger, if the number is bigger than 1, any number bigger than 1, it's going to compress. What I mean by compress is it just kind of makes it a little steeper, the ray together. So by compressing the ray together, if you think about this, in this case from the parent one, it's a much narrower one. If we would have had the absolute value of 3x, it's even going to be more compressed, getting closer and closer together. If it was 10, it'd be even closer. If we think of the number, as we looked at that last one, is between, and this goes for both positive and negative, between 0 and 1, instead of compressing our graph, it's going to spread the graph out more. It's going to make it wider, is how I kind of like to think of it. But it spreads the graph out. If it would be a positive 1/2, it's going to make it much wider like this. And if it would be negative, that V shape is still there, but it is now going to be a wider graph than the parent function as we look at that. Pause it if you need to, write this down. Again, take a look at what we did up above with those graphs and their equations. And then it's going to ask you to practice, and we'll be doing this in our homework too. And the first thing you really want to think about is our graph going up or down? Is the absolute value positive? Since this is positive, we know our graph has to go up. That's the first thing we want to think about. Next thing, where is our vertex? Well, we said before that this moves it down 3. Well, down is on the y-axis. So that means my vertex has to be down at a -3. What is this telling us? X minus 1. Remember, your gut is to think left, but how would I get 0? And I'd get 0 by making this a positive 1. So our vertex is going to be located at 1, -3. Once I get to that point, it is always that same shape. If there's no number out in front, that same shape as our parent function. And now we don't have to make the table of values. One thing I would suggest is that you check the points, or at least one of them, to make sure you're doing it right. How do you check it? Plug in this point, 2, -2. When you check it, 2, -2, that's saying that -2 should be equal to the absolute value of 2 minus 1 minus 3. Well, this is going to be 1 minus 3, and that does equal a -2. Again, we're going to start with this one. Oh, this negative, what does it tell us? The first thing that negative tells us is that our graph should go down. Next thing it tells us, what is our vertex? So always finding the vertex. +4, we love that. It helps us find the up 4. +2, well, what do I add to x to get 0 in here? I add a -2, so my vertex, if I'm looking at that, the vertex is going to be at -2, +4. It's going down in that same V shape, so I have it going down. And again, a nice easy point to check at this one, this point right here, 0, 2. If I was going to check it, just to make sure I'm on track, I check the point 0, 2. That means y is 2. That equals the absolute value of x. 0 plus 2 is just going to be the absolute value of -2 plus 4, and that equals 2. So this point does check. Hope this is making sense. Again, go back over it if you need to, and we'll see you in class.